Okay, so today we're going to be talking about different ways you can use similar figures to solve real-world problems, sometimes called attributes of similar figures, so it's kind of like different properties of similar figures. And the first two problems we're going to be looking at are similar to ones you've already done before, but I just want to point out to you that in the last video we talked about how corresponding angles in a similar figure are equal, and that their corresponding sides are proportional. Well, sometimes it's difficult to figure out which side is which. And so I just want you to see that in this triangle here, they've told you which angles are corresponding. And I know it may be difficult to see, but they have put these little arcs here to show you that these sides are the same as these sides right here, because there's just one little arc in each of these. This is an isosceles triangle because this angle is equal to this angle and this angle is equal to this angle. And then the difference is in this third angle here, instead of one arc, there are two. And I'm just gonna make it a little easier for you to see. So what this is telling me is that this angle is the same as this angle. So even though this triangle has kind of been rotated a little bit, I can still see which sides are corresponding. And then the sides opposite corresponding angles are the ones that correspond in the sides. So that makes sometimes the proportion a little easier to set up. So in this first one, if I'm trying to determine if something's similar, I'm going to set up a proportion. So I might start with the large triangle and compare it to the small triangle. Set up my boxes. Okay, and I'm going to pick maybe this side right here, 6 in the large rectangle. It's going to correspond. Okay, so this angle corresponds to this side. So that same angle with the two arcs corresponds with this side, so the 3. And then if I pick a second side here, okay, I can see that it's across from one of the arcs. So I'm going to pick the side here that's across from one of the arcs. So that would be 3.5. That's my dog making all that noise. And then we're going to cross multiply and see if these give us the same value. So I know that 3 times 7 is 21. And what I need to know is what 6 times 3.5 is. So I'm going to go ahead and multiply this over here. 6 times 3 is 18, plus 3 is 21. I have one decimal place here, so that is also 21. So were these similar? Yes, because their cross products are similar. All right, so here I have rectangles. So I'm going to do maybe small to large this time. So in the small rectangle, I'm going to pick a side. Let's say 3. It's going to correspond to the shorter side over here, so 4. And then if I start with the long side, I get 6, and the long side here is 9. Cross multiply to find this cross product, so 3 times 9 and 6 times 4. 3 times 9 is 27. That is not the same thing as 24, so these are not similar. Okay. Oh, did you see that? In the third example here, this time there's no picture, and so you have to pay attention to the letters they give you. So they're telling me rectangle ABCD. So we're going to label it as ABCD. You need to keep them in order. Is similar to rectangle WXYZ. All right, so I just went around. I started in the same corner with both of those. Okay, it says, what is the value of AB? So that's this one. That's what I'm looking for. I'm going to call it X. If WX, so that's between W and X, is 8 feet, and AD is 12 feet, so between here and here is 12, and between WZ is 16. All right, so this time I had to draw my own picture, but then I'm going to use that picture to set up my proportion. All right, so if I'm doing maybe large to small, and that's just going to depend on how I drew it. It's not necessarily true. Or maybe the first rectangle to the second rectangle, maybe that's better. So I'm going to pick corresponding sides. So in this one, if I start with the short side here and the short side here, I know that in the first triangle I have 12, in the second triangle it was 16 because they're in the same position. When I get back to the first triangle, x is in the same position as 8. All right, and then to solve it, I'm going to cross multiply 12 times 8 and 16 times x. If I don't know 12 times 8, I'm going to multiply and get 96. So I know that 16 times x is equal to 96. So now I'm going to finish this, I need to divide by 16. So 96 will go, can be divided by 16 6 times. 6 times 6 is 9, or 6 times 16 is 96. So my answer is 6. X is going to equal 6, and the value of 6 is 6 feet. So that's what I was using for the other measurements. All right. And number 4, triangle DEF is similar to GHK. So again, I need to set up my own picture, but I need to make sure that I label the triangles in the right order. So if I start here with DEF, I need to go in the same direction when I do GHK. All right, so I'm going to start in the same place, go around. The value of DF, so between these two, is what I'm looking for. If GK, so this value right here is 3.4, EF is 2.25, and HK is 9. So right here, HK is 9. All right, so setting up that proportion, looks like X is corresponding to 3.4. So I'm going to do first triangle to the second triangle, do X and 3.4. And then I'm going to go back to my first triangle, so 2.25 is going to correspond to 9. And I'm going to do that cross product. So 2.25 times 3.4. Careful with these decimals. We did this in the last chapter. 4 times 5 is 20, carrier 2. 4 times 2 is 8, plus 2 is 10, carrier 1. 4 times 2 is 8, plus 1 is 9. Start with a 0. 3 times 5 is 15. 3 times 2 is 6, plus 1 is 7. 3 times 2 is 6. Add these up. You get 7650, but don't forget you've got 2 decimal places here, 1 here, so I need a total of 3. When I move my decimal over 3 places, I get 7.650. So I know that 7.650 is equal to 9 times x. I don't know what x is. I need to work backwards. So instead of multiplying, I'm going to divide. So now if I divide 9 to 7.65, I don't have to have that 0 there, so I'm going to drop it for now. I can't divide 9 into 7, so I'm going to bring up that decimal. 9 will go into 7.6, or I can put a 0 there if you prefer. 9 will go into 76 8 times. 8 times 9 is 72. When I subtract, I get 4, bring down the 5. 9 will go into 45 5 times, and then I'm done. So the value of x in this problem was 0.85, and it is in inches. All right. Okay, so here's another use for similar triangles. This is called indirect measurement, and this actually works. So sometimes what happens is you can, it's not easy to measure the height of a building. A person, yes, maybe, but not a building. So what happens is people use similar figures. You can, instead of measuring how tall a building is, what you can measure sometimes is its shadow, okay, because that's along the ground. And so we can use that to set up a proportion. All right, so the shadow of the man is 13 feet. The shadow of the building is 39 feet. The height of the man is 6. The height of the building is what we're looking for. All right, so in this case, we might do the actual height compared to the shadow. All right, so the actual height of the man was 6 compared to his shadow, which is 13. And then if we do the same thing with the building, the actual height of the building, we're going to call h. The shadow of the building is 39. All right, and once you set up your proportion, you're solving it the same way. So 6 times 39 is 54. 6 times 3 is 18, plus 5 is 23. So I'm going to say 234 is equal to 13 times h. And then to solve for h, I need to divide by 13. So 13 will go into 23 one time. I subtract, I get 10, bring down the 4. 13 will go into 104, let's say, maybe 8. 8 times 3 is 20. 8 times 8. So my answer then is 18. H is equal to 18, and this is in feet, so 18 feet. So using the shadow on the ground, I was able to measure indirectly the height of the building without actually having to measure it. I used what I knew. Okay, so you can do the same thing even if they don't show you the picture. You can draw your own picture. So a lamppost casts a shadow that is 15 yards long, and a mailbox casts a shadow that is 5 yards long. So I can draw my little lamppost. Bad picture, but it's casting a shadow that would be on the ground that's 15 yards long. All right, a mailbox. Okay, that's a little flag for the mailbox. Okay, it's casting a shadow also along the ground that is 5 yards long. Okay, so in this one, I can see that this is going to be my triangle here. The mailbox was 3 feet, and then the height of the lamppost is what I'm looking for, so I'm going to call that X. So set up your proportion, so I can do the actual height, again, to the shadow, and then draw your boxes. All right, so in the first one, the actual height is X. I don't know that, but the shadow is 15. In this one, the actual height of the mailbox was 3, and the shadow is 5. And then I'm going to multiply 3 times 15 and 5 times X. 3 times 15 is 45. I set that equal to 5 times X. And then if I don't know what 5 times what number gives me 45, then I'm going to divide 5 into 45. That'll go 9 times. So X is equal to 9, and this is in feet, so 9 feet. That's my answer. So that's the height of the lamppost. Okay, and the last example, again, an 8-foot tall statue stands in the park and casts a shadow that's 16 feet long. A dog stands next to it and is 3 feet tall. Okay, how long is the dog's shadow? Okay, so in this time, I'm looking for a shadow. Okay, so let's see. If I've got a statue, here's my statue. It's casting a shadow. It's 8 foot. The shadow's on the ground. It's 16 feet. And here's my triangle. And the dog is standing next to it. Okay, and casting a shadow. Maybe the dog's right. I'm just going to draw a different picture for the dog. And I don't draw dogs. That's a dog. Okay, it's casting a shadow. We don't know how long the shadow is, but we know the dog is 3 feet tall. All right, so use that to set up your proportion. So if I'm doing the actual height to the shadow height, and I'm going to use 8 and 16. Over here, I'm going to use 3 and X. All right, solve your proportion. 16 times 3 is 48. So 8 times X is equal to 48. If I don't know what that is, then I'm going to divide by 8. 8 will go into 48 6 times, so X is equal to 6, and this is in feet. So the shadow of the dog is 6 feet long. All right, so again, there are a couple ways to apply similarity to real-world problems, and one of them is using shadows to indirectly measure things. All right, thanks.